have fringe, bangs, like that, but different way. I got a C. I don't have anything. Is this? I think she got this way. Hands.
Hello. Hello. Here we are. Okay, let's see if I can get some music on. I'm just chilling out. I'm doing some research on tunneling for a video I'm gonna make. Let's get some music on. Some chills and bedtime beats. Hello. Tunneling and DNA mutations. Let's see. I don't see my Twitch. Welcome to the chat room. Welcome to the chat. Hey, there's somebody in here. I don't know who, but maybe a bot. Let's see. I'll let people know I'm on Twitch.
Tell me you golf.
Let's go here. Hello. Where's mine? I'm gonna take. Should I just do it? I'm not gonna do that. I'm not gonna do that. All right. Hey. Is that better? Is that better? It's a little fuzzy. Okay. Doing the research here. Let's move this eraser like this. And I'm gonna minimize blender. A lot open, bro. Hope my computer can keep up with all this. MATLAB. This is what I have down here. Let's show what we have here. Let's put this down here. Nice. Okay. Need to bring my MATLAB over. We don't want to write a bunch of files. This thing writes files like crazy. Let's run this thing. A little tunneling down there. Where's my good. Alright. Let's go here. We're gonna figure one. Gotta do figure one. Let's do that. Numeric figure handle is not supported. That's not good. Not good, Joe. Alright, let's do this right. Numerical figure handles. Let's do it like this. Done. Set. Fig. Do that. There we go. I see it tunneling down there. Move it over here. Make this bigger. Make this smaller. A little more real estate on Twitch, feels like, than we do on TikTok. Let's put this in a loop. Bro, you better not have written some stuff. What is this? That's not the way that works at all. Why did it rewrite? History. Where is this? What's down here? Interesting. Oh, it must be setting a position. Yeah, let's not do that. I don't care about that. Stop. Stop, bro. Gotta start it over. Okay. Put it over here. Just want to get it out of the way. That's really slow. I think I need the stop blender. I think we're good with blender. A lot of stuff running. Let's not run that. Welcome to the stream. If you have any questions, physics questions, put them in the chat. Bro, what's going on here? Alright, understand. Run MATLAB again. Some moderate amount of tunneling there. Let's take the barrier down. The little red line here is the barrier, the energy barrier. And one of the qualities about tunneling is that you don't necessarily have to have a higher energy than that barrier to be able to leak across it. So let's lower the barrier. That's V naught. Let's make it very small. And then we really don't have much tunneling. I mean, we don't have much reflection. There's not really any tunneling. You just pass right through. So you can see there, not much is going on with the wave. Some interference. Some will get reflected. Tiny bit's going to get reflected, as you can see down there. There's a tiny bit reflected, but not much. Not much. This window cropped. Filters. Crop path. The bottom. I don't think I want to crop the bottom very much. I got the bottom cropped, Joe. Let's not crop the bottom, and then the top's a little cropped too. We'll bring that back. Maxwell's equations on top. Sweet. Alright, let's try again. It's running slowly. What else do I have open? Quick cells. Not much. It's fine. Alright, back to this research. Tunneling and DNA mutations. So protons and hydrogen bond base pairs, AT, GC, or mis pairs like GT, sit in double well potentials. Quantum tunneling can move to a rare tautomeric well. What does this mean? Tautomeric. Tautomers. Tautomers are structural isomers. Chemical compounds that readily interconvert. Chemical reaction interconverting the two is called tautomerization. This conversion commonly results from the relocation of a hydrogen atom within the compound. So, we have an example of that. Let's see here. Download. Let's grab this bad boy. SVG. What's an SVG, bro? Jeez. Okay. Let's grab this for the briefing. Maybe. That's pretty cool, actually. And my charts, we're gonna pop it in. Might put it in before I do all this stuff here. Tautomer. So this is a tautomer here. Notice that the H has gone from being over here with the oxygen to hanging out with the hydrogen over on this side. Interesting. It's got the same amount of stuff in it, the same elements. They're just arranged slightly differently. And it looks like it made it a polar molecule as well, which is kind of cool. Okay. So that's what that is. Let's close this. Tautomer. Let's pronounce it. Bro, like, say the word. Okay, it's not gonna say it. Oh, I wonder if I can show my chat. Crap. How do I get my Twitch? My Twitch here. I'm gonna move my Twitch over here. It's here. Alright, again. Well, all I ever need to see is the chat. I don't know if anybody will show up to chat, but if you do, I'm here. While I research this. So let's close this. The role of quantum tunneling in altering the structure of nucleotides to each other and causing a mutation event in DNA has been a topic of debate for years. Here, we introduce a new quantum mechanical approach for analyzing a typical point mutation in DNA strands, assuming each codon as a base state, as superposition codon states could provide a physical description for a set of codons encoding the same amino acid, and there are transition amplitudes between them. We choose the amino acid PHE and ILE as our understudy biosystems, which are encoded by 2 and 3 codons respectively. We treat them as large quantum systems and use double and triple well potential models to study the fundamental behavior of them in interactions with our harmonic environment. We used the perturbation theory to calculate transition probabilities between the codons, which encoding the same amino acid and determine transition rate of some point mutations. I think that's a typo there. Moreover, we evaluate the quantum biological channel capacity for these transitions to show that the channel capacity depends on the system-environment interaction via the dissipation factor gamma. The obtained results demonstrate that the tunneling rate is under the control of capacity of the corresponding biological channel. Let's see, I can share the screen. Let's just share this for now. Let's get that shared. Window capture. This is what we're reading right now. So let's see here. We're just running this. Actually, let's run down here. Let me set this up to run. So it should run nice and slow while we talk about this. Let's do this at 0.4. Oops. There we go. The obtained results demonstrates that the tunneling rate is under control of the capacity corresponding biological channel. In other words, the reduction in quantum channel capacity prevents the quantum tunneling rate to be increased. Okay. In 1944, Schrödinger, in his famous book, What is Life?, attempted to explain the notion of life based on the basic laws of physics. I did not know that this is a thing. That's pretty cool. Let's see. Amazon. Let's see what this is here. $0.99. What is life? What is this? Nice. And add it to cart. We're going to go back to entire paper. Oh, here it is. Okay, let's move it to here. I'm going to, here we're going to add the crop filter. There we go. This book, he claimed that quantum mechanics would soon solve the mysteries of emerging of life. He speculated distinguishing living organisms from non-living ones would be possible with appearing some sort of new behavior arising from quantum mechanical effects. His book strongly influenced the subsequent research activities in biogenetics and biophysics. One of the most prominent examples is the famous work of Watson and Crick, in which they got inspired by Schrodinger's book and proposing the now ball and rod method for the structure of DNA. Model is used multi-scale simulations to study the structure and dynamics of protein DNA complexes. It accounts for the intrinsic twist and curvature, anisotropic bending properties, and electrostatic charge of DNA. The model predicts several topologically different conformations of DNA loops and analyzes them over a broad range of model parameters. Watson and Crick DNA model. Okay, that's pretty interesting.
Do you recognize this molecule? This is DNA, or deoxyribonucleic acid. By the end of this video, you will be able to identify the key structural features of DNA, as well as describe the importance of those features for function. During this video, we will look at different representations of the DNA molecule to better view certain details, but all views represent this same structure. Inside the cell, you will most commonly find double-stranded DNA, in which two strands intertwine to form a double helix. The most common form of the DNA double helix, which is what we will discuss here, is also called B-form DNA. Now, let's move to a more simplified representation of DNA to discuss the details. We can unwind the double helix like this, so that we can see the chemical structure inside. Each strand is a polynucleotide, meaning the strand is made up of many individual units called nucleotides. A nucleotide has three components: the 5-carbon sugar, a phosphate group, and one of 4 possible nitrogenous bases: adenine, guanine, thymine, and cytosine. The nitrogenous base is always attached at the 1' carbon of the sugar. If we count from there, we can see that there is a phosphate between the 5' carbon of one sugar and the 3' carbon of the neighboring sugar. The sugar is called deoxyribose because it is missing a hydroxyl group at the 2' carbon, which is present in ribose. Because of this, nucleotides in DNA, deoxyribonucleic acid, are called deoxynucleotides. Nucleotides attach to each other in the DNA strand by phosphodiester bonds. The phosphate group of one nucleotide binds to the 3' oxygen of the neighboring nucleotide. Thus, we can see that the sugars and phosphate groups make up the DNA backbone. The carbon numbering is key to describing the directionality of the DNA strand, 5' to 3'. Looking within the sugars, there is an intrinsic orientation difference between the two strands. On the top strand, you can see that the 5' carbon of each sugar is on the left, and the 3' carbon is on the right. The opposite is true for the bottom strand. Reading left to right, that makes the top strand orientation 5' to 3', and the bottom strand orientation 3' to 5'. These strands are also sometimes called Watson and Crick. Keep in mind that this double-stranded DNA is still a double helix, and we have simplified the representation by flattening and unwinding the helix here to better see the atomic structure. Although the nucleotides come together through covalent bonds in the backbone, the two DNA strands interact through non-covalent hydrogen bonds between the bases. Each base forms multiple hydrogen bonds with its complementary base on the opposite strand. Bound together by hydrogen bonds, each unit is called a base pair. The hydrogen bonding contributes to the specificity of base pairing. Thymine preferentially pairs with adenine through 2 hydrogen bonds, and cytosine preferentially pairs with guanine through 3 hydrogen bonds. Thymine and cytosine are called pyrimidines, characterized by their single ring structure, and adenine and guanine are called purines, which have double rings. The geometry of the AT, or TA, and GC, or CG, base pairs is the same, allowing for symmetry and base stacking in the helix. This mostly has to do with the distance between the backbones and the angles to which the base is attached to the backbone. Other base pairs, like GT for example, do not have the same geometry, cannot form strong hydrogen bonds, and disturb the helix. The double helix structure of DNA is highly regular. Each turn of the helix measures approximately 10 base pairs. In addition to the hydrogen bonding between the bases, the stacking of the bases also stabilizes the double helix structure. These pi-pi interactions form when the aromatic rings of the bases stack next to each other and share electron probabilities. The regularity of the helical structure forms 2 repeating and alternating spaces called the major and minor grooves. These grooves act as base pair recognition and binding sites for proteins. The major groove contains base pair specific information, while the minor groove is largely base pair non-specific. This is because of the patterns of hydrogen bond acceptors and donors that proteins can interact with in the grooves. In this way, the DNA can be acted upon in either a sequence-specific or non-sequence-specific manner, allowing proteins to position themselves correctly in the genome to carry out their designated tasks. This is the DNA double helix, and you've now learned the structural features that influence its function. We hope you've enjoyed exploring this amazing molecule with us. Nucleic acid, and one of 4 possible nitrogenated DNA, in which 2 strands intertwine to form a double helix. The most common form of the DNA double helix, which is what we will discuss here, is also called B-form DNA. Now, let's move to a more simplified representation of DNA to discuss the details. We can unwind the double helix like this.
1944, Ernst Schrödinger, in his famous book, What is Life?, attempted to explain the notion of life based on the basic laws of physics. So, as we saw, this inspired Watson and Crick. Made the ball and rod model for the structure of the DNA. Although the definition of life is controversial and there is no universal agreement about its meaning, many researchers are working in bioscience believe that all living organisms are information processors. Several research to date have contemplated that living organisms may process biological information through a quantum mechanical manner. They have suggested some fundamental aspects of quantum mechanics, including superposition principle, entanglement, and tunneling, may play an essential role in the function of biological processes. Today, by knowing the structure of DNA, finding some objective evidences through the experimental and quantum mechanical studies that Schrödinger organisms have been strongly enriched. According to Paul Davies, the 60th anniversary of publication of Schrödinger's book, The Quantum Mechanical Treatment of Living Organisms, adds a radical solution to the problem of life, leading to direct emergence of it from the atomic world without the demand for intermediate role of chemistry. Whoa. There are some reasons that claim that information processing at the quantum mechanical level can be done more quickly in classical level by several orders of magnitude. Some features of quantum systems make them possible and improve their performance. Furthermore, quantum mechanics enables an automatic discretization of genetic information. In several publications, it is prevalent to study biological systems using the so-called quantum-like models, e.g. Asano et al., in their applied quantum-like approach to explore an analogy in the behavior of biological systems. These models do not claim to present real quantum effects, but propose that they can describe macroscopic processes using quantum-like statistics. Quantum-like models are also useful to interpret and discuss some interesting features of genetic systems, such as computational power and generative capacity. In addition to these approaches, the idea of investigating the genome mutation using the quantum description is initiated by the seminal work of Delbrunck, Schrödinger, as well as Watson. Taking some notes. Okay. In addition to these approaches, the idea of investigating the genome mutations using the quantum description initiated by seminal work of Delbrunck, Schrodinger, as well as Watson and Crick, were the pioneers in this aspect. They proposes some mutations in DNA structures are caused by quantum jump events, such as tautomeric shifts in single protons of nucleotides. Loudon, in 1963, pointed out that tunneling as a mere quantum mechanical phenomenon plays a role in altering the structure of nucleotides, giving rise to mutations. Loudon was the first one who used a two-step model for describing genetic noise, in which a base substitution of codon transition is due to 1. Formation of the tautomeric state of a nucleotide in a non-coding strand of DNA caused by a proton transfer between two neighboring sites with a nucleotide. 2. Insertion of an incorrect base to the coding strand of DNA due to the unusual base pairing of tautomeric form, which may lead to a point mutation. Subsequent transcriptions and translations of a mutant pattern will appear at each level of gene expression. After his remarkable study, proton tunneling and its subsequent tautomeric mutations have been frequently studied. McFadden and Al-Khalili in 1999 suggested that the genetic code might be considered as a quantum state described by wave function, so that superposition of states might occur, which leads to spontaneous mutations in DNA strands. They have proposed that model-based most common model to obtain transition products and codons is employing Ludwig's double well model. This approach is still an attractive research area, judged by recent studies. Current recent research. Several biophysicists have been interested in understanding how information flows from DNA to protein using the fundamental concepts of quantum mechanics. Up to now, most common models for investigating information transfer process are based on biological quantum channels, although they are not sufficiently general to incorporate all events happening during protein synthesis. In 2008, Kalafaridis presented a model for the information transfer from DNA to proteins using quantum rules. He constructed a block diagonal Hamiltonian matrix for a typical protein chain in which each block is matched with 1 to 20 different amino acids in the protein structure. In construction to the Hamiltonian, he assumed every codon is described by a base state and reasoned there are transition probability amplitudes between a set of codons which are matched with the same amino acid. Considering each block as a Hamiltonian related to one of the amino acids, here we take a quantum mechanical approach to calculate the transition probabilities between the codons belonging to a similar set. Present work, we choose the amino acids PHE, phenylalanine, and ILE, isoleucine, which are encoded by 2 and 3 codons respectively. Treat these systems as large quantum systems under interactions with their harmonic environments. Due to the formation of a Hamiltonian matrices, we use a typical double and triple well potentials method to study the fundamental behaviors of them, including macroscopic quantum tunneling. According to Loudon, we consider the states of the nucleotides as a superposition of tunneling and untunneled states. It is possible to calculate transition probabilities between the codons encoding the same amino acids to determine the transition rate of some of these point mutations. Moreover, we evaluate the quantum biological channel capacity for the corresponding transition of PHE and ILE amino acids. This paper is organized as follows. In section 2, we introduce throughout 2 subsections Hamiltonian matrices necessary for the quantum mechanical description of our biological large systems, i.e. PHE, ILE, respectively. Although we evaluate the transition rates between the corresponding codons with detailed calculations, in addition we evaluate quantum biological channel capacity for the proposed models of both PHE and ILE. In section 3, we conclude and briefly discuss about the implications of our results in calculating the transition probabilities from both physical and biological perspectives. Some additional relations and variables which are used in mathematical derivations in section 3 are presented in Appendix A. Wait, I don't have Appendix A? Bro. See if I can just find this bad boy. It wasn't an archive. I mean, this is interesting. This is the math between transition probabilities. But, not what we're looking for. Ooh, pretty disappointed I can't get this paper. Oh, I'm down Lifshitz. It's a pretty nice briefing.
residential area. This should be played at high volume.
It's not the full text. I'm getting a runaround here, bro. Looks pretty good, actually.
Cleaning on my clothes till I dream again. Sorry wasn't good, but we wanna be friends. Give a little lift, maybe if I try to change the fact you know we'll rather be back. I don't want your pardon, I don't like the cold. We don't see it coming, we know how it's going. Maybe it's just something that you say. Everything means nothing till it goes away. somehow how to love you and how I could know you better and better. Oh, how I need you, and if I could see you more than I see you now, then I could see somehow how to need you, to let you need me too, forever and ever. My breath is your breath, and my water's your water. I couldn't be fed and not share in this altar, 'cause I cannot be you alone. I wanna know what you thought. I wanna see what you thought. Baby, on the way down, I'm gonna hold you up. And baby, on the way out, we could dissolve as one. When you let her feel it, when you cut up choosing to believe it, that you're gonna stay, that you're gonna stay, stay.
Oh, that's a heck of a potential there.
You make the bed, but I gotta lie in it.
Fits the data pretty well though.
Fighting a silent war again. You overspend till your words feel counterfeit, wasting my breath in your defense, grieving before it ends. Find myself studying the
Oh, excuse me.
Driving out to meet old friends. Jenny's got a new last name. Ethan's with a girl that I loved at 15. I'm living off minimum wage. Really things ain't too bad. Said I'll probably still see you around, but it hit me like a train down memory lane. Stuck a for sale sign in the ground. That's okay. That's alright.
Oh hey. I'm reading about quantum tunneling in DNA for DNA mutations. I'm gonna make a video on it. So I was just doing a little research. Sorry, I forgot to check the chat. It's been so quiet in here. The music's probably a little loud. How's it going? Everything good? Were you on TikTok a little? It's not. Yeah, it's kind of quiet. Yeah. I'm probably going to get off here in a minute. Man, I've been spending an hour reading biojournals. It's quite the slog, man. Switch to bedtime beats for a minute. Try to relax. Okay. My quantum mechanical system stopped running down there. Oh, hey, Mom. Yeah. So I have a workaround right now. I have two audio interfaces. And so I can stream this like this off of OBS using one audio interface. And then stream on TikTok using TikTok Studio, because the last time I did it, the only problem I had was sound. Like the video could be shared between them, but for some reason the sound couldn't be shared. So that just means like I'll take this mic here and plug it in and use it for probably Twitch, and then use this one for TikTok. This one's a little nicer. It sounds a little bit better. But this one is interesting because like it has more lows in it. Yeah. Yeah, for I have a multi-stream OBS plugin that I can do like YouTube and Twitch simultaneously. And that's not an issue, but what I want to do is I want to stream portrait and landscape simultaneously. I'll ultimately I'm just probably going to buy another computer. I run everything off of a laptop, so I'll probably like buy a little cheap but good enough PC. This mic here. I have this mic and this mic. This mic's louder. This one's more balanced. Yeah, you think this one sounds a little bit better over here on this side? Just kind of use them both when I go on TikTok. They capture different parts of the spectrum, frequency spectrum. Yeah, so bring these freaking papers. What I have, like my workflow is I usually, it's pretty good now. I've been using, not a chat GPT gives like references. I've been using it to help with science because I can go to the references, and that's what I'm doing now, which is pretty good. Before it was really sketchy. Like I didn't like using it for doing any of my TikTok stuff. Oh, the dark one. Yeah, this one here. Yeah, it's a better mic. This is a better mic. This is a typical streaming and podcast mic. This is more of this little gray one is a utility mic. It's used to like mic cymbals and like different angles of a guitar and stuff. I just have them both plugged in for now. I mean, the audio source has 2 plugs. I had 2 mics. I was like, you know what? I'll just plug them both in. But yeah, I'll have to switch them on each. This is my audio interface. Like this. This is my audio interface. The one I'm not using right now. It's nice. See, trying to get some recent articles. Towards a calculation. Oh no, see, this is the one I couldn't find. I couldn't find a free version of it. Like, come on, bro. We shouldn't have scientific articles locked in paywalls. To be fair, I mean, look at this shit. Excuse my language. Tautomerization pathways. So I did figure out what a tautomer is. It's one of these. On the top here, I have a molecule and its tautomer. On this side. It has the same stuff in it, but if you notice, like, wait, what's going on here? Where's my cursor? On this side, it's got an H2N, and one of the H's from over the O over here from the oxygen has come over to this side. So this is a tautomer. It's got the same elements in it. They're just slightly rearranged. In this case, it also made it a polar molecule a little bit. Looks like they added a plus and a minus. But I guess the tunneling is across from here to here. It's the tunneling they're talking about. Oh, the bulletin. Oh, that's so weird. That's so weird. I assume that like you and your daughter both have like the same kind of cell phone, like iPhone or Android. Could it be an issue like that? That'd be stupid. I mean, TikTok usually doesn't have issues like that. It's really weird. I don't know. I joined the under the desk news bulletin just to see what it's like on the receiving end of a bulletin, because I don't even know how it shows up on people's pages or anything. Yeah, y'all both have iPhones. That's what I have. You probably know that. Yeah, I mean, I just the double helix is called B-form DNA. I'm learning some stuff about DNA though. This guy Paul Davies, I read a book by him like 20 years ago, maybe 30, I don't know. But he says that quantum could give emergence to life directly from the atomic world without chemistry, without needing chemistry. And that seems insane. Like, you got to make all these complex molecules. Oh, you haven't seen any bulletins? That's interesting. Yeah, they're starting to come out. Probably a week and a half ago or something, that I got a message from TikTok that there was this new feature. I don't know. I try new things, so I don't know if there's a setting. I do a little research on it. I think they're pretty neat. I've lately been putting out to vote like what videos I should make. So that the 3i video I made was based off of the vote. And this log I'm going through is based off of the vote as well. Let me see how. Maybe I'll get off the lucky here and people have voted for the Rogue Planets one, which would be. That's pretty close. Rogue Planets is at 41% and tunneling and DNA is at 47%. And the third topic I proposed was little g on Earth, how you can calculate the gravitational acceleration at different points on Earth. 9.8 meters per second squared is kind of like what we typically quote. What's neat too is in the bulletin, it shows you like who voted for which one, so I can see, so I could prioritize, like if there's some people that are like subscribers or something, maybe I could give them like 5 votes or something. Who is the sadist that voted for the DNA one? Like, how are you gonna make a physicist do a video? I can't believe I even proposed it. Yeah, I don't know these people, Lord. They don't come in my life. Well, no, there's a few there. I know. Yeah. Niels. Of course Niels would vote for that. David Zorbitz, C-Bar, Face Kermit. Yeah, there's a few people I know on here. I mean, Free. The Flat Earther. Like, I DM with him sometimes. I don't know if you know Free. He's like one of the younger curly-haired Flat Earther. And he gets a little heated. Oh, Dr. Greg. Of course, Dr. Greg's going to vote on the... He'll probably like that video. See, now I have to make it good, because Dr. Greg is probably going to watch it, and I really like him. He's definitely going to blow up. Like, those debates he does, they're just entertaining. He's just an entertaining fella. He's smart. He's got a good personality. He's got a good scene set up. We're definitely going to see him get big. I don't know if you ever go in those lives, if you know Dr. Greg. I almost wanted to put on my bulletin that I'm on Twitch. But it's like, I don't know, man. I don't know if I should. It feels like I'm like, I'm a government contractor, work on, like, we're not supposed to use like government resources to do like corporate work. And that's what I feel like I'm doing if I like go on TikTok and publicize my Twitch. The last two videos I did all right. The one on the 3i Atlas James Webb, and then the one before on the neutrino imaging of the sun. I tried to work on my hook, like get people to like stay just more than just like a second or two, you know. I think that's so critical. Like most of my videos, like people just leave within a second. And it's just and I understand too, because like sometimes when I'm scrolling, man, it's like I do the same thing. Like I know within a second or so if I'm gonna watch the video. You gotta have a hook. Oh, I hear you. Nate, what's up, bro? You found me. I'm on Twitch. Oh my god. Yeah, I'm just in here chatting with Prayer. Got 3 viewers now. This is a record, man. I'm big deal on Twitch now. Yeah, I am. Hey, Nate, I've been using these bulletins, these TikTok bulletins, like putting polls up and stuff, asking people what they might want to see and communicating with the community. You should start a little a message board for your community. Probably get a good engagement in there. Were you on YouTube? Did you try to message me? Oh, okay, good. I was like, I hope I didn't like. I know we're going to try. Am I on YouTube right now? Oh shit. Oh, how am I live on YouTube right now? Oh my god. Bro, I gotta get it together. I think you're I can't believe I'm live on YouTube right now. Hold on. Let's go to YouTube. Jeez. So I did start. I mean, it would make sense because when I set up the broadcast, it was like to YouTube, I think, and then I'm doing the multi-broadcast to Twitch. So that's not great. Let's see. Oh no. How do I get to view my channel? I'm sorry you were chatting with me and I wasn't responding. I didn't even know I was live there. How do I get, let's see, YouTube, do they have a, live? I'm trying to see how I even see my lives. Bro, I need to be more responsible. These are not very exciting lives I'm putting up there on YouTube. I don't even see how to see myself live on YouTube right now. Videos, watch later. Home? Your live viewer there, but how do I get, hey Nate, how do I get my live viewer? Alright, hold on, let me share my screen. Wait, that's the wrong one. Let's see here. Alright, here's my YouTube. Alright, let me bring this over here. Is it on my channel? View your channel? Manage videos. Where's my Twitch? I go to my channel, view live. Click live tab, just watch your own live. So I'm on the live tab. Oh. Oh. I am live. Okay. This is bad, Joe. Alright, now I need to figure out how to not broadcast this. This is my problem. In OBS, when I'm starting to broadcast, yeah, then mute it. Like literally, like mute the sound, or you mean like mute the Uh-oh. Like sound mute it, or can I right click and... Oops, I keep tapping on it. Oh. I don't know if you were in there when I was kind of reading that white paper. Yeah, I muted it. Okay. But I gotta find a better way than to start. That means that every one of these streams I've done on Twitch has actually gone on YouTube. Also, that's a little embarrassing. I mean, I know I'm live, so I'm not like running around in my underwear or anything stupid. See y'all. Bye, Flora. Okay. Well, Nate, if you want to get together tomorrow or in the next few days and do a video, let me know. Crap, I've been on YouTube a lot. That sucks. Well, I mean, it doesn't suck. I've been on Twitch, so. Which is interesting because I didn't think I was multi-broadcasting. That's just me not using the tool properly. But when I start to stream, it does seem like I think I start to stream like to YouTube, and then crap. Never going to grow my YouTube channel if I'm not like, yeah. What I'll do is I'll probably just set the stream key to Twitch. Oh crap, I got to get my TikTok stream key. All right, well, that's interesting. Yeah, well, if I stop the stream right now, I'll stop both of them because I have a multi-stream going. But I only I set the stream up to go to YouTube, but then on the multi-stream, I only started Twitch, so I thought I had to start both of them, and like YouTube was just like get me connected to the web somehow. I'm ignorant on all this stuff. I probably should spend a little more time to do that. I think if I end it now, though, it'll just end the stream on Twitch as well, which I probably need to do anyway. It's like I've been on here an hour and a half. It's like 1 o'clock. I gotta get up for work. Oh no, I gotta go to the doctor with my wife tomorrow. Yeah, I have... Oh, it doesn't show up there. Yeah, it'd be nice if I could, on YouTube's side, like, make it private or something to where it's not going out. That's what I need to do. Alright, bro. I'm gonna go to bed. Get in touch tomorrow if you want to do anything on 3i Atlas. There is it's got a tail. So people have observed a tail now. It's a freaking comet, bro. I need to find out if it's like a carbon dioxide comet, if that's going to be a chance for it to be brighter than if it was like water. I think ultimately just depends on how much you're outgassing, like more of like the volume. Who's creating wonders? That sounds interesting. Like on a three person collab? That sounds interesting. Oh, interesting. Yeah. Man, I wish we could all get together and like have the chat. Like, I don't think we ever found a good way to do that though, and like capture the quality. Yeah, 10 mils. I mean, dude, you got, I don't know where you at, 1.2, 1.1? You got a mil yourself. I mean, I think once you get up to those numbers, man, it's like it's hitting a lot of people just immediately, right? Yeah, I mean, if you want to do like we did before, Nate, where you just have like some questions, and I can send you some clips. Okay. So it would be 1.2. Yeah, you said, and I remember you saying like once you got to 1, you feel like you would quickly get like 100K more. Like it would keep you well above 1.2. I know, man, it's so crazy. You got those 0.2 in just like weeks. Can't tell you how long it's taken me to get like 25K, like almost a year. So I got 50 like off like one good viral video, and then like, so hard. I think it's like I get about 1,000. I get 1 follower for like every 1,000 views. Who would be the best example of tackling the rumors? Oh, yeah. Yeah, there's some rumors, that's for sure. Yeah, cool, let me know. I'm game with whatever. Up 1,000 every hour, losing 500 every hour. I do notice losing followers sometimes too. That's like, I guess, as you know, I mean, as long as you keep like content coming out, you gain more than you lose. And maybe that's, I don't know. I would like, it's like, the cynical part of me is like, that's TikTok trying to push us to do stuff. But like, does that mean they just gave us like bot viewers, or push our content in a way that makes, I don't know. Yeah, we can chat tomorrow. Just hit me up. I'm doing like a regular work day, like 9 to 6 type thing. So I'll be free after. But that creator program has motivated me. I mean, that's why I'm on here doing the research. That's why this stuff's up on my screen about DNA and reading about tunneling. I made this little tunneling simulation. You can see my tunneling simulation I made. I made a video on Blender. But on MATLAB. And let's see. You can see the video down there. It's a wave hitting a barrier, and then some of it reflects, and then some of it transmits through the barrier. The transmitted part is the tunneled portion. Oh, excellent. Yeah, my last couple of videos have been getting pretty good hits. I mean, for me, it's okay. 30K or so. It's better than the 3. Hook. The last 2 videos I have worked on getting a hook. You know, I've been talking to you, listening to the advice in that Discord server. So trying to bring the quality up. I think I have decent enough equipment to get the sound of the video, but that's not going to help you if you don't have the story and the hook. So I think I'm getting better at the hook, but it's like the narrative, building the actual story. That I don't plan enough for all that. Yeah, the Atlas. So yeah, all of the Atlas videos do well, man. People are searching for that. Like I noticed, like from the data, there's a lot of people that hit that from the search on the keyword on 3i Atlas. And then I noticed that somebody tagged like me and Blitz on a video to a conspiracy theory video on 3 Atlas, but Blitz answered, and he always does such a good job. The hook is so tricky, yeah. So, but that's another thing. I probably should do a debunked video, like, because there's so many conspiracy theories out right now out on 3i Atlas. I don't do a lot of those, but I don't know. By the end of it, we could be like known as the 3i Atlas people. I'm making all these videos on it. Yeah. All right, bro. I'm gonna hop off. Yeah, we'll talk tomorrow. Yeah, and if you have a third that wants to get in on it, just let me know. If they have questions, we can hop on a group call or whatever, Discord call if you need. And sorry I wasn't on YouTube, like, interacting. Can't believe. I mean, I should have known. All right, bro. See ya.